Hello everybody. Today I'm going to talk about parametric equations and context. So for this first question, we have two different ships and they're being measured in different ways. Okay, so let's first look at this first ship, this HMS ship. And we know that the linear equation or the rectangular equation is 2x plus 50. And one of our parametric equations given with the parameter t is x equals 3t. So our goal is pretty much to find out what is y equals blank in terms of t. So when you look at this problem, you want to start with your rectangular one, which is this one. And you just want to substitute x with 3t. And the reason why you want to do that is pretty much, remember, if we want y as a function of t, we're going to want to replace x with t. So by doing this, we get y equals 6t plus 50, and we have fulfilled what the question has asked us. So this is for the HMS. So next, we're given the parameter equations of HMS. But then there's a new boat called junction, all right? So for our new boat, so there's two boats in the situation. HMS, we got everything that we needed from question A in the problem. And now these two new equations, which are both parametric, describe the USS junction. So we're wondering if these two different boats are ever going to go on the same path. So to see if they go on the same path, I think it would be useful to know what is the rectangular equation for junction, right? Because we know that 2x plus 50, like if we think about 2x plus 50, 50 is here. We know that that's what that graph looks like. But what we're trying to figure out is what is the path for this new boat. So when I try to do this problem, we see two equations. We got x in terms of t, and we got y in terms of t. So what I'm thinking is if we take this x function, which is x equals 5 over 2t plus 10, let's solve for t first. So if we solve for t, so we'll subtract 10. And then if we want to get rid of 5 over 2, we're going to multiply by the reciprocal. And we're going to get t equals 2/5 times x minus 10. Why is this helpful? This is helpful because I'm going to take this and I'm going to substitute it into this function. So remember, our other parametric equation in terms of y and t is y equals 5t plus 70. Now I'm going to take this and substitute that for t. So let's go ahead and do this, actually. It's getting a little messy here, so this is what I'm going to do. I'm going to go back to this t equals and just go ahead and distribute. And then we get 4. So now for t, I'm going to write 2/5 x minus 4 plus 70. I'm going to distribute, and I get y equals 2x minus 20 plus 70, which is y equals 2x plus 50. Man, this is really weird. So we just did this whole problem, and even though this part, which I'm going to highlight, do you see that the positioning is different for B than it is for A, because we have 3t here and we got 6t plus 50, but both functions are actually the same. So the answer to this question is yes, both ships are on the same path. So both ships are following the line y equals 2x plus 50, but where the ships are actually positioned are in different places. And we know that they're positioned differently because the parametrics, or the two equations that are given in terms of t, those functions tell us where we are on our path. So what we're going to do for C is we need to figure out at any point, are these two ships going to collide with each other? So we know that both of the paths are the same because they're both represented by y equals 2x plus 50. What we don't know is whether or not these two are going to collide with each other. So what we need to do is we need to figure out if there's a time that they'll ever be equal to each other. So for instance, let's take x equals 3t. That's for the first function. And let's take x equals 5 over 2t plus 10. Both of these functions are going to tell us at this x value, my time is blank. So we want to figure out if we can find a time where these are both equivalent. So since x equals 3t and x equals 5 over 2t plus 10, what we're going to do is we're going to set them both equal to each other. And we're going to see if we can find out a time where they'll both be the same. So what I'm going to do here is I'm going to subtract 5 over 2t on both sides. So I'm going to get 3t minus 5 over 2t equals 10. And if we think about it, 3t is the same thing as 6t over 2. And then you're going to get 1 over 2t equals 10. And then you're going to multiply both sides by 2, and you get 20. So what this is saying that both of these ships are going to run into each other in 20 minutes. So that is devastating. So how can we know if this is true? Well, in 20 minutes, we can substitute this in and see if we get the same values for both of these. So I'm just going to erase all this for a moment. Sorry. This is y equals 6t plus 50. I'm going to take this. I'm going to move it over here for a second, okay? And then we have x equals 3t. So those are the parameters for A. And then for B, we got these two over here. So we just checked the x's, right? We know the x's are the same because we set them equal to each other. Let's try the y's. So let's say if I do y equals 6 times 20 plus 50, I'm going to get 120 plus 50, which is 170. So now what I'm going to do is I'm going to go to the y for B. I'm going to do 5 times 20 plus 70. And do you see how I get 170 as well? If I do this for the x, the same thing should happen. If I do x equals 3 times 20, that gives me 60. If I take x equals 5 over 2 times 20 plus 10, 5 times 20 is 100. 100 over 2 is 50. 50 plus 10 is 60. So do you see how at 20 seconds, both ships are going to be at the coordinate 60, 170. So what's important here is we kind of have two variables and one parameter, x being our horizontal distance, y being our vertical distance, and t being our time. You could both be in the same location, but if you're not there at the same time, then there's not going to be a crash. But here, unfortunately, there is a crash. So that's how you would proceed with number 1. So let's try number 2. And number 2 is a little different. So for number 2, we are given the rectangular equation of a Coast Guard boat. And in 0 minutes, the boat is at 50, 20. We want to write, and it's moving 2 millimeters to the left each minute. So let's think about this. So we have, once again, another linear equation, and our boat is now at 50, 20, And every time our x value is going to go to the left 2 times. So if I was going to make an equation for this situation, the first thing I would ask myself is, when t equals 0 minutes, and I'm talking about horizontal position, what is my x value at 0 minutes? Well, the question says I start at 50, 20, so I know my x value has to be 50. So how am I changing my x values? Well, x equals 50, and then every time I'm going to subtract 2. I'm going to subtract 2 every minute because that's what it says, right? 2 millimeters to the left each minute. So I know that's why x has to equal 50 minus 2t. And I hope that makes sense. Where am I in 0 minutes? My x coordinate is 50. What's happening every minute? Well, I am subtracting 2 millimeters every minute. So letter B says, now to write a parametric equation for our y. So the problem doesn't really say much about how y is changing. So I know when t equals 0 minutes, I know my y value is 20. But besides that, I don't know how it's moving. So what I'm actually going to do is I'm going to take this equation, x equals 50 minus 2t, and I'm going to solve for t. So to solve for t, and you'll see why I'm doing this, I'm going to get x minus 50 equals negative 2t, and then x minus 50 over negative 2 equals t. So I know now what t is, and I'm going to take this and I'm going to substitute it for negative 2x plus 120. So I hope you see what I'm trying to do here, is I'm trying to get rid of x. So, funny thing is, I got too excited and I did too much. Because you see here, actually, I'm going to erase this for a second. X equals 50 minus 2t. All I really need to do is take this and substitute it for x. I'm so sorry about that. So do you see here that y equals negative 2 times 50 minus 2t plus 120, and we get y equals negative 100 plus 4t plus 120, and we get y equals 4t plus 20. And that is actually our equation here. So what was my mistake that I did previously? Well, I was solving for t by accident and getting t in terms of x. But what I wanted is I want to get rid of x, and I want x in terms of t. So this is actually set up perfectly because x is in terms of t. So do you now see that we have our y value in terms of t now? So last question. So we have a motorboat that ran out of fuel at 20,80 on the screen. How many minutes would it take at 50:20 to reach the motorboat, assuming that the motorboat does not drift? So we know that at 50,20, that's where we started at 0 minutes, and we want to know what is the time that passes at 20,80. Well, let's take 20,80 and label it. This is x, and this is y. So to find the time, you can take either equation that you solved for an a and b. So let's say that I take x equals 50 minus 2t. If I substitute 20, which is my horizontal distance, I can solve for t. And you see how I get t equals 15. So t equals 15 minutes. So I would be able to reach this boat after 15 minutes. How can you double check that we did this correctly? Well, let's take our y, which is 4t plus 20, and let's substitute 80 for y, and let's see if we get the same time. Because what we're saying here is to get to this position, it would take me 15 minutes to go across horizontally 20, And it should also take you 15 minutes to go vertically 80, because that whole trip takes 15 minutes to get to that point. So when I sub minus 20, I get 60. And you see when I divide by 4, I also get 15. Which means that you know we did it correctly. So just remember, parametrics. What is cool about parametrics is you are able to think about horizontal and vertical distances, which not only give you distance, but it also gives you position. So how long does it take me to get to this position? I hope this helps. And remember, this is just a start. So if you have any questions, feel free to shoot me any questions. And take care.